asking about this motion. My question to you is, or my point now, what I'm going to put is, we are going to bother about two things. One is slope of the graph. Next is area under the graph. Slope of the graph and area under the graph are two parameters about which we are going to be worried about. Okay? Now, slope. What is the meaning of the word slope? Acceleration. Slope means acceleration. If a graph is there, how do you find its slope? Ulta you are telling. y2 minus y1 by x2 minus x1. Okay, but good, you tried. So slope can be found for any curve if you write y2 minus y1 by x2 minus x1, which can also be told as change in y by change in x, which can also be told as tan theta. So you will learn slope of any graph can be found out by various methods. If you have a graph known, if suppose I am having coordinates known, suppose this coordinate is x1 comma y1, this coordinate is x2 comma y2, then the slope of this graph can be found out by the formula y2 minus y1 by x2 minus x1. That is, what is the change in the y-axis, what is the change in x-axis, you divide both, you get the answer of slope. More easier method than that is by having the theta known, of the graph and finding the tan theta. Suppose I say you that this graph is inclined at an angle of 30 degree. Then what is the slope if I ask you? What is tan 30? 1 by root 3 is the answer. Are you getting my point? So slope of any graph, the two ways of finding it is, one is y2 minus y1 divided by x2 minus x1. Second method is tan of inclination. If you know the graph's inclination, you can talk about the slope. For example, if I draw a graph like this, and if I ask you what is the slope of this graph, what is the answer? How 0, man? What is theta here? 90. So what is tan 90? Not defined or infinite. So I can say that slope here is infinite.
Sir, only tan will come, sir.
Only tan will come, tan 90, tan theta. Yes, sir. Okay? Same way, if I draw the graph like this, ST graph, if I am drawing the graph like this, and if I ask you, this angle, suppose I gave you theta is equal to 120 degree, then what is the slope? Slope is equal to tan 120. Once again math came. This also I have taught in the bridge course. Tan 90 plus 30. How much is that? Minus cot 30. What is cot 30? Root 3. So minus root 3 is the answer. So please have attention here. If you want to find slope of any graph, the easiest method is tan theta. But if theta is unknown to you and you have coordinates known to you, then use y2 minus y1 by x2 minus x1, you will be easily getting what is the slope of the graph. Okay. Second parameter I told was what? Area under the graph. Area under the graph, what is there in that? Whatever graph is given to you, you just want to find, suppose I am drawing a graph like this, and if I ask you what is the area under the graph, what you will do? You will find this area. It will be like a trapezium. You can find the area of trapezium. If yes, if you are want to do like this, triangle and rectangle, do like this, your wish, whatever comforts you. So area finding is simple. A arc is given or a graph is given, just find the area below it, and if you find the area below it, that will give some information to you. Now what information? So first you copy what you want to copy from here. I'll go to the next board. Those who are writing, please copy whatever you want to copy from here.
Sir, can you once again repeat the last graph? That is the DC.
You're talking about which graph, man?
Sir, that last graph, sir.
This,
ABC.
yeah.
Yes, sir.
I said that if you have any graph given and if they ask you to find the area under the graph, then
Yes, sir.
you draw the two lines meeting the time axis and just find what is the area. In this case, it can be a triangle area and a rectangle area, or some of you can even take it as a trapezium area if you are good in trapezium. Both will give the same answer.
Yes, sir.
Okay?
Thank you.
Yeah.
Yes, sir.
In my infinity graph, area gatana.
Tell me what is the area? 0. If you have a graph like this, what is the area below this? Only a line is there. Line will not have any area. So 0. Indumati, why you came so early today?
Sir, there was no network available here, sir. That's why, sir.
Reason is there for everything, no, Indumati?
No, sir. No, sir.
Okay. Copy whatever you want to copy from the board. I am going to change the slide. 1 minute. Make it fast. If you want to write something, please copy it fast. All of you are done? Fast, fast, fast. Make it fast, make it fast. So, Indumati, since you joined late, just for you I am saying, up to now we have just talked about how to find slope of the graph and how to find area under the graph. Slope can be found by two methods. One is y2 minus phi1 by x2 minus x1. It means for any graph, if you have the coordinates known x1, y1, x2, y2, by this formula you can find its slope. Second way of finding slope is, if you have theta known, then by using tan theta, you can find the slope of this graph. Simple, okay? Second thing is, if they ask to find area under the graph, suppose this is the graph, then you drop a line here on the time axis, and then whatever area comes below, that will be the area. It can be a rectangle and a triangle, or if you are good in mathematics, geometry, you can take area of trapezium also. Okay, Indumati? Yeah. So can I change the slide, if you permit me? If you have missed something, you can write it later also. It's going to be there in the video. Yeah. Now, after you have learnt how to find the slope of any graph, how to find the area under any graph, now I can comfortably tell you what does it give you. That is, I told you three kinds of graph: displacement time graph, velocity time graph, acceleration time graph. In all these three graphs, I said you two parameters. One is slope, another is area under the graph. Displacement time graph slope will give you velocity. Velocity time graph slope will give you acceleration. Acceleration time graph slope will give no information. For school, no information only. No jerk here. Okay. Area under AT graph gives velocity. Area under VT graph gives displacement. And area under ST graph gives no information. So how to remember it simply? If you are finding the slope, move in this way. That is for ST graph, velocity, VT graph, acceleration, AT graph, nothing is in front of it, so no information. For area, go in the reverse direction. For AT graph, velocity, VT graph, displacement, before ST graph, nothing is there, so no information. That way you can remember. It is just for remembering things. Okay? So now I came to know that if I am having a displacement time graph and I am finding the slope of this graph, what I am going to get? I am going to get velocity. If I am having a velocity time graph and if I am finding slope of it, what I am going to get? Acceleration. Okay, this was your understanding? Okay. Now let me draw a graph. Displacement time graph like this. If I ask you, comment on the motion, what will be your answer? Constant what? Constant velocity. What? Constant velocity. Good. What, Kanishka? Loudly. Common sense. Object at rest here. Displacement or remains same throughout. It means what? And why layman's thinking? Be little professional. What is theta here? What is theta? 180 or 0, no yaar. See here. It is kept like this. Theta is 0. If it goes this like this only, theta will increase, no? If theta is 0, what is tan 0? So what is tan theta? Slope. Slope of ST graph gives what? 0 velocity means what? Object is at rest. Are you able to understand my point? So this graph indicates that object is at rest. Do you agree with me? I'll give another thing. Please pay attention. Think and say, okay? Uniform velocity. Okay, what is the meaning of uniform velocity?
Equal distance in equal interval.
That is called as uniform motion actually. Uniform motion. Uniform motion, it means velocity remains same. Why did you say that? Because equal distance covered in equal intervals of time. Okay, what about this?
Velocity is
Non-uniform motion. Okay, very good, Sarvanaram. Then what about this? Retardation, Sri Krishna is saying. Okay, then Harin Krish, what about this, man? Ah. Retardation, okay. Kishore, what about this, man? Non-uniform motion. So, if it is a straight line, uniform motion. If it is a non-straight line, it is non-uniform motion. Don't think like that, first of all. Today's class gets over. Everybody in the class, all the 20 online people and all the people who are sitting in the offline, should be able to feel the graph. It's not only about seeing the graph. Now you should be able to, okay, this is the graph, this is speaking to you. Graph speaks to you actually. You know how? See here, please pay attention. Theta remains constant. Do you agree with me? If theta is constant, tan theta is also constant. If tan theta is constant, velocity is also constant. If velocity is constant, acceleration is 0. Do you agree with me? Because acceleration is rate of change of momentum. Velocity. Acceleration is rate of change of velocity. Velocity remains constant, acceleration becomes 0. Obviously, it is uniform motion, no problem, no doubt in that. But you should not say uniform motion because equal distance, equal interval of time. No, you are coming in 11th standard now. So in 11th class, theta is constant, tan theta is constant, velocity is constant, acceleration is 0. Because these graphs you can answer only in that case. Now see, here what is happening to theta? Check properly. What is happening to theta? Theta is increasing. If theta will increase, tan theta will also increase. Because, why I am saying so? Theta 0, tan 0, 0. 30 degree, tan 30 is 1 by root 3. 45 degree, tan 45 is 1. 60 degree, root 3. 90 degree, infinite. So 0, 1 by root 3, 1, root 3, infinite. So as theta is increasing, tan theta is also increasing. So theta increases, tan theta increases. Tan theta increases means slope increases. Slope increases means velocity increases. How will the velocity increase? If you accelerate, isn't it? So it is positive acceleration. Why I use the word positive? Because acceleration can be negative also. Retardation, deacceleration we call, deceleration, isn't it? So this is positive acceleration where the body's velocity is increasing. Same way, see this graph, what is happening? Theta is decreasing. So tan theta will be decreasing. Tell me, Kanishka. Yes, Kanishka.
Yes, Sir, how will acceleration?
See, I am not getting direct acceleration, Kanishka, I am getting velocity. But since velocity is increasing, it must be acceleration, no? What is the meaning of increasing velocity, Kanishka? How will the velocity increase? If you drive a bike, if you want to increase the velocity, how will you increase? If you put accelerator, isn't it? Driving a bike, I hope you have seen or you have drove the bike, otherwise you have seen your parents driving the bike. When they are accelerating, velocity increases, am I right? Am I right or not, Kanishka? So in that way I am saying acceleration. I am not finding acceleration directly from the graph. I am finding velocity only. But since the velocity is increasing, I am commenting on the acceleration. Are you getting my point, Kanishka?
Yes, sir.
Same way, since tan theta is reducing, velocity is reducing. Velocity is reducing, it means what? Negative acceleration. Now negative acceleration means retardation. Driving a bike, put brake. What will happen? Vehicle will stop. That time also velocity is reducing. That is only called as retardation. This is the graph of acceleration. This is the graph of retardation. But both of them are non-uniform motion. Uniform motion, both are non-uniform motion. But difference is here velocity is increasing, here velocity is reducing, or positive acceleration, negative acceleration. I hope it is clear to you. Next, when I come to this graph if you see, once again theta is constant, am I right? If theta is constant, tan theta will be constant, and if tan theta is constant, velocity will be constant. If velocity is constant, acceleration is 0. Oh, very good. Does it mean that this graph and this graph are same?
No, sir.
Uniform? Deacceleration. I told acceleration is 0, man. Then how deacceleration will come?
Decreasing, sir.
What decreasing?
Acceleration.
I said acceleration is 0. End of story of acceleration.
The displacement is decreasing with time.
So,
The direction is changed.
Direction change.
Sir, is it negative?
negative?
Sir,
Acceleration cannot come, Shrish. Krishna, something you are saying.
Negative displacement.
The direction.
Yes, Srinidhi, I heard your answer. That's why I am silent. I am not talking your name. You are right. Yes, Krishna.
The direction has changed.
Direction has changed. See, I'll explain this to you also. Once again, a deep concept. I am throwing a ball above against the gravity. Ball goes up and then it reaches the maximum height because definitely, go to terrace. Definitely the ball cannot go in the space by your throw. Am I right? Because for throwing something against the space, and in the space we need at least 11.2 kilometer per second speed. That is called as escape speed. You will learn in the upcoming classes. Escape velocity. So now, if you throw something with some velocity, it goes up, 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 stops and comes down, 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 right? One time the object went in this direction, one time the object is coming back in this direction. So one of the direction of velocities must be negative. If I take this as positive, this will be negative, or this as positive, this will be negative. Are you getting my point or not? So in this case, it is velocity which is positive. Why I say velocity is negative here? How I say velocity is negative? Very good concept is there. See here, tan theta, right? What is theta here? Obtuse. Am I right? That is tan 90 plus theta. You know very well, I have taught in the bridge course, tan 90 plus theta is how much? Minus cot theta. Very good. So we can see very clearly negative is going to come. It means it is going to have a negative velocity. Are you getting my point? Negative velocity does not mean the velocity is changing. Velocity may be constant, but it may be in the opposite direction. Are you getting my point? So you should be very clear in this. Velocity in both the cases are not changing, it's constant. But here it is in positive direction, here it is in negative direction.
Negative.
And if I comment on the last graph that I have drawn here, this graph is not possible itself.
Yes, sir.
Same time a body cannot have two different positions. So this graph is not at all possible.
Yes, sir.
If you have understood this, take 2 minutes of time and copy all this. Graph pair. Graph pair வந்து uniform motion but velocity is in opposite direction. Okay, these both are uniform motion. But here the velocity is positive, here the velocity is negative. Make it fast, please.
Completed, sir.
The screenshot taking, man.
No, sir.
Okay. And you study units and dimensions for 2 minutes.
No, sir. No, sir.
Sir, if possible, can you explain the last graph again, sir? I don't understand it.
Yes, why not? I'll explain you. So if you see the last graph, in this last graph of ST graph, that is displacement time graph, if you see, if I draw any line, for a particular time, there are two values of displacement, right, Indumati? I hope you are seeing.
Sir, yes, sir. I see.
Is it possible for a particular body to have two different positions in a particular time? Can you be in the home as well as in the academy at the same time?
No, sir.
Yes, you are there, no, by the live conferencing. Okay. But actually you are not. So physically we cannot be present in two different positions at a particular time. So this kind of graph is not possible. So if a question comes like this, Indumati, see here. Is this graph possible?
No, sir.
Once again, not possible. Why? Because at the same time we are having 1, 2, 3, 4, 5, 6 position. Possible only in Dr. Strange movie, multiverse. Isn't it? Huh?
Sir, yes.
Otherwise not possible in our real universe, what we have, a single universe. But see, Indumati, if a graph is drawn like this, is this graph possible?
Yes, sir.
Yes,
sir.
possible. Because for every time it has a specific position, isn't it? So possible. I hope you got the concept.
Could you explain the difference between uniform and constant? Uniform velocity, constant velocity.
Don't say half word. Uniform.
Uniform velocity.
Uniform. See, there's nothing called uniform velocity. It's uniform motion and non-uniform motion. Uniform motion means velocity is constant. And if velocity becomes constant, acceleration becomes 0. And non-uniform motion means velocity is changing. It can either increase or decrease. It should not remain constant. So non-uniform motion is when the acceleration is present. It can be positive acceleration, it can be negative acceleration. But velocity should change. Are you getting? Any doubts are there further? Uniform motion is A0, V is constant. Non-uniform motion, A has some value, it can be positive or negative. It means velocity should change, either it should increase or decrease. Got it? In fifth case, yeah, velocity is negative. Make it fast, make it fast. Completed? Shall I go to the next page? All of you permit me to go to the next page? Thank you.
Yes, sir.
Yes. So now we have seen various displacement time graphs and we have commented on each motion. I hope by now you understood that whenever a graph is drawn in front of you, you will start seeing the graph with the help of theta, nothing else. So if you want to select, for example, if a question comes in the examination where a graph is like this, then you should be able to feel the graph by seeing the theta. See what is happening to theta here. Theta with respect, how decreasing here? Constant, no?
Yes, sir.
Theta is
I
constant but obtuse. It means velocity is negative. And beyond this point, theta is once again constant but acute. So velocity is increasing. How? Yeah. Positive. Remove from your mind that negative means decreasing, positive means increasing. Not like that, Tambi. Positive and negative is by direction, not by increasing, decreasing. Are you getting my point? So here also theta is constant. Theta is constant, but theta is constant and obtuse. Theta is constant and acute. So here you will have positive velocity. Here you will have negative velocity. So whole graph is uniform motion, but in this point the velocity is becoming 0 also, right? You know what is happening? Something is moving like this or maybe like this with a constant velocity, then stops and once again comes back like this. That is the graph for this. If I go from here to there at a constant velocity and stop, once again I come back from here to here at constant velocity. This is my graph. Understanding? One direction, another direction. Direction is changing, at one point becoming 0 also. That's what I told you. Graph is given, just don't try to mug up the graph. You cannot. Especially if you are preparing for competitive examination, you have to understand how the graph works. Okay? Shall I proceed further then? Okay. Now we are going to talk about velocity time graphs. I talked about displacement time graph. Now what I am going to talk about is velocity time graph. Once again, please pay attention and listen. I will give time for writing. Concept clearing is the first objective of you. Okay. Next is only copying. Notes anybody can give. Learning is rare. Okay. VT graph. Simple. Raghav, comment on the, nobody else will say anything. Raghav, comment on the motion. What is the type of motion? Okay, how do you say uniform motion? Velocity remains same. Again, you are saying correct, but you are using layman's approach, or I should not layman's approach, 9th level approach. Now you are in 11th standard. Very good. Theta is 0 degree, so tan 0 will be 0. It means what? How, man? VT graph slope gives what? Acceleration. So acceleration is 0. 0 acceleration means velocity is constant. This is the way of saying in 11th standard. Since theta is 0, tan theta is 0, acceleration is 0, so velocity is constant. Got my point? I hope. Now, Kashika, if you are hearing me, fever girl Kashika, unmute yourself here if you have not slept. Yeah. Shall I?
Yes, sir.
Tell me about this graph. Comment on the motion.
It's a uniform motion, sir.
Uniform motion. How do you say that?
Can you repeat, sir?
Question is in front of you. VT graph, comment on the motion. You please unmute for 10 seconds. Yes.
Yes, sir.
Yeah. Now tell me about the motion.
So the theta is constant here, sir.
Very good. Then
If the theta is constant, the tan theta is also constant.
very good.
acceleration would be 0.
Oh, theta constant, tan theta constant, acceleration will be 0. Or acceleration also will become constant, Kashika.
Sir, acceleration also.
Kashika, understanding what I said now?
Yes, sir.
Tan theta means slope. Slope is constant. And what is the slope of VT graph gives you? Acceleration. So acceleration is constant. What is the meaning of constant acceleration, Kashika?
So the value would be the constant, sir. Like,
Will the velocity change?
no, sir.
How can velocity not change if acceleration is there? See, these things should be very clear. That's why I'm questioning you. Kashika, don't mute here. Yes. You said acceleration is constant. You are perfectly right. My next question was, acceleration is constant. Does it mean that velocity is 0? Think and say. You may be wrong, no problem.
Yes, sir.
No, yaar. Why it has to be 0? Acceleration is constant. It means rate at which velocity is changing is constant. I will give an example to you. I know you are confusing. I will give an example to you. Example can be very simple. I am drawing a time sheet here, which is from 0, 1, 2, 3 and 4. Okay. I am drawing the speed of the vehicle. These things I have taught already in Sunday's class, right, Sai Varshini? But you forgot what to do. Okay. Please pay attention, everybody who is attending the class. So 0. Kashika, I hope
Yes, sir.
everything is fine. Velocity is 0. For the first second, velocity became 20. Everything is in meter per second, okay? Meter per second.
Yes.
Then it became 40. Then it became 60. Then it became 80. Okay, Kashika? This is the velocity value. If I want to write what is acceleration, acceleration is v minus u by t. So 20 minus 0 by 1, how much will be that? 20 meter per second square, right? In the first second. Then 40 minus 20 by 1, how much is that? Same 20. 60 minus 40 by 1, same 20. So everywhere it is 20, 20, 20 only. Are you understanding, Kashika?
Yes, sir.
Whether the velocity is changing.
No, sir.
You are daydreaming or you are sleeping.
Yes, sir.
Velocity is changing only, no yaar.
Yes, sir.
Acceleration is changing.
No, sir.
Thank God. So acceleration is constant, but velocity is changing. Understood?
Yes, sir.
So when acceleration is constant, does not mean velocity is 0.
Yes, sir. Thank you, sir.
Tell me, Raitanya.
Sir, what if velocity is constant, like in previous?
If velocity is constant, what will be acceleration, Raitanya?
0.
Over story.
Sir, but it is confusing.
You are confusing between constant acceleration and 0 acceleration. Bad day today. Okay, control. You have a lot of things to say, I know. Don't say. Listen, okay. I am repeating this. Raitanya, pay attention. I have given an example to you. You know how to drive bike? No? Then it's difficult for you only. You have seen your parents driving vehicle? Okay. So, suppose your mother is driving scooty. Okay? And she starts the scooty. Initially it will be at rest when she starts. Then for going forward she will accelerate. Okay? Suppose in 1 second she went to 20 meter per second. Next 1 second 40 meter per second. Another 1 second 60 meter per second. She is driving fast, no problem. Again 1 second 80 meter per second. Within 4 seconds from 0 she went to how much? 8 meter per second. My God. Okay. 80 meter per second. Okay. It means, what is the meaning of acceleration? U by t, change in velocity by time. So in the first second from 0 to 1, if I calculate, how much is the velocity changed from 0 to 20? 20 minus 0 by 1, v minus u by t. How much is that? 20 minus 0 by 1, how much is that? 20. In second, from 20 it went to 40. 40 minus 20 by 1, how much? 20. In third second, 60 minus 40 by 1, how much is that? 80 minus 60 by 1, how much is that? It means what? Velocity is changing. It means it is being accelerated, but it is accelerated at a constant rate. Are you getting? If she starts the bike, she goes at 40 meter per second, but she remains at 40 meter per second only throughout. 40 meter per second, 40 meter per second, 40 meter per second, 40 meter per second. It means what? Velocity is constant. What will be acceleration? 0. Are you getting my point? Constant velocity means 0 acceleration, but varying velocity will have some acceleration. This is the example of constant acceleration. Anybody has doubt, feel free, I will explain once again also. Is it clear to everybody? Gayana, not clear? Clear, no?
Sir, can you repeat something in this?
The last thing that you said.
Huh?
The last thing that you said.
Mr. Karthikeyan M, I will repeat once again. In this example that I have given, a person is driving a vehicle and at every 1 second the velocity is increasing. But for every 1 second, how much is the velocity increase? 20 meter per second only is increasing. So from 0 to 1, 20 meter per second, 1 to 2, 40 meter per second, 2 to 3, 60 meter per second, 3 to 4, 80 meter per second. It means for every 1 second, how much is the velocity changing? 20 meter per second. And what is acceleration? Change in velocity by time. So 20 meter per second by 1 second will be 20 meter per second square. So for every 1 second, since the acceleration is same, 20 meter per second square, 20 meter per second square, suppose, sir, I want to check in 1 to 4 second. Same thing will come, check. 80 minus 20, how much? 60. By 4 minus 1 is how much? 3. How much is that? 20. If you check from here to here, check. 60 minus 20, 40. 3 minus 1, 2. 40 by 2, how much? 20. It means that always the acceleration is remaining constant. Are you getting my point? Constant acceleration means velocity will change, but at a constant rate it changes. Got it? Karthikeyan, understood something?
Yes, sir.
Okay. Next graph. This graph, Lohita Shri, if you are there in the class, unmute yourself.
Yes, sir.
Comment on this. One by one, step by step.
Non-uniform motion, sir.
Okay, don't say directly the conclusion. You tell me step by step. Theta, what is happening to theta? Step by step. As I taught in the previous thing, step by step, right? Same way you say me step by step.
Yes, sir.
Please tell me.
So, theta will be
Increasing, decreasing or constant?
theta will be increasing, sir.
Yes, increasing obviously. See here, less, more, much more. Theta is increasing. So what will happen to tan theta?
It will also increase.
And what tan theta gives you?
Acceleration
So acceleration will also.
increase.
So this is a graph of increasing acceleration. As far as you are concerned about non-uniform motion, Lohita, even the previous graph is non-uniform motion only because velocity is changing, right?
Yes, sir.
But these two graphs, are they same? No. This is also non-uniform motion. This is also non-uniform motion. But here, non-uniform motion at a constant acceleration, here non-uniform motion at an increasing acceleration. So here also velocity is changing. Here also velocity will change, but at a constant rate it will not change. It will change at an increasing rate. It means, I will give example to you. A person is driving a bike and he is driving at from 0 goes to 20 meter per second. Then goes to 50 meter per second. then goes to 100 meter per second. Let us not go further. I can write 180 also, right? 180, what is there in that? 180 meter per second. Within 4 seconds, from 0 it went to how much speed? 180. Okay, let me calculate the acceleration. 20 minus 0 by 1, how much is that? 20 meter per second square. 50 minus 20 by 1, 30 meter per second square. 100 minus 50 by 1, 50 meter per second square. 180 minus 100 by 1, 80 meter per second square. Right? So, Tarika, if you are not reading units and dimensions, can you tell me what is happening here? Velocity is changing or not?
Sir?
Is velocity changing or not?
Yes, sir.
Is it increasing or decreasing?
Increasing.
What is happening to acceleration? Increasing or decreasing?
Increasing.
Yes. So, velocity also is increasing, acceleration also is increasing. That is this graph, where velocity is changing and acceleration is increasing. In this case, velocity was changing, but acceleration was constant. I hope you are getting some clarity about how these two are different. It is confusing, but you have to. Any problem, Raghav? Any problem? Mr. Guru Sharan, understanding? No means not understanding. No doubt. Pritish, clear, no? Kirtana Rajashekar. Aditya, understanding, sure? Online people, anybody has any doubt in this? Mr. Kishore from SSM Nagar, understanding?
Understanding.
What about you, Shakti Varshini?
Understanding, sir.
If you have any doubt, don't hesitate to ask me. Soumya, everything is clear? Soumya, if you are hearing me, if everything is clear up to now, whatever I have taught? No reply from Soumya. I hope you are hearing me, Soumya. Please check your connection. Muhammad Arshad, things are fine.
Yes, sir.
Shall I proceed to the next topic?
Yes, sir.
Not next topic, actually, next graph. Now the graph became like this. Who will help me? Shoaib Ahmed will help me. Unmute yourself, Shoaib Ahmed. Yes. Comment on the motion. Step by step.
Theta is decreasing, sir.
Great. So,
Tan theta will decrease, sir.
great. So,
Acceleration will decrease.
very good. So, how is it different from these two graphs?
Sir, the first one is theta is constant, sir. So acceleration is also constant, sir. The second one, acceleration is positive, sir.
Okay.
In this graph,
Got.
retardation is going.
So, you are trying to say that in this graph, the body is retarding, its acceleration is negative. Am I right?
Yes, sir.
You are not right. I will tell you why.
This one is reducing, sir.
What is reducing, Mr. Krishna?
Acceleration is reducing.
Okay, so acceleration is reducing. Very good. Now, Indumati, unmute yourself.
Good.
So, you also think that in this graph, velocity is reducing. Are you thinking like that? Yes or no?
So, the acceleration is reducing because theta is reducing.
So, if acceleration is reducing, will velocity increase or it will reduce? You should say little loudly if you are confident.
It will decrease.
It will decrease. Okay. Aditi, what is your opinion? Velocity will decrease. Obviously, it will decrease.
No, sir. If the acceleration is less, more means the velocity, it changes constantly, sir. Like it will just increase.
Calm. Here, acceleration is not constant. Acceleration is decreasing. Acceleration is decreasing. Whether velocity will increase, decrease, or remain same.
I don't know. I think it will increase.
Okay. I'll come back to you. Kishore, what is your opinion, man? Velocity will increase, decrease, or remain same?
Sir, Remain same.
Velocity will remain same, acceleration will become 0, Mr. Kishore. Forgot that. So,
Okay.
no chance of velocity to remain same. Okay, think for some more time. Harin Krish, Mr. Harin Krish.
Sir,
Any comments? Velocity is increasing or decreasing?
sir, velocity increase ಆಗ sir.
Velocity is increasing.
Yes.
Okay, but acceleration is reducing. Think for a while. Dwarkesh, what is your opinion? Shri Krishna, you can lower your hand. I'll give you a last chance. Dwarkesh, yes. Velocity will decrease, you are thinking, right, Dwarkesh? But in this case, acceleration is decreasing. Now velocity will increase or decrease?
Velocity will decrease only.
Decrease. This is what is the most confusing part of this chapter. Okay? I'll make it clear for you. I'll try to make it clear for you. Please pay attention now. Everybody, please pay attention. Now, imagine the same time and I am drawing some velocity values once again. A person is driving the vehicle. So, who is driving? Lalit Ramna, you want to drive? Vanama. Say, okay, Shrish is driving. So, Shrish, you are driving Maybach, okay? And 0, velocity is 0. 1 second, your velocity became, Maybach you are driving, no, your velocity became 60 in 1 second itself. Second, your velocity became 100. Then from 100 it became 120. Very slow, man. Okay, fine. From 120 it became 130. Okay. Now everybody who told the answer as velocity should reduce. Think now. Is velocity increasing here or decreasing here? Increasing. 0, 60, 100, 120, 130. Velocity is increasing only, right? Let us check the acceleration. 60 minus 0 by 1, 60 meter per second square. 100 minus 60 by 1, 40 meter per second square. 120 minus 100 by 1, 20 meter per second square. 130 minus 120 by 1, 10 meter per second square. So, velocity increased, but acceleration is reducing. It is quite possible a decreasing acceleration can still increase the velocity.
No, but it will eventually become constant. No, sir.
Yeah, it should at one point of time. That's
So
why
now
the graph goes
sir,
like this.
What about the before graph, sir?
This
So
graph.
velocity increases in that one, sir. No rate, sir. No, it looks like it increases. That's good, sir.
That's why I'm saying what your mind is saying. No, graph going like this, velocity is increasing. Graph going like this, velocity is decreasing. Don't think like that, Indumati. You have been taught now the graph should be seen not because this looks decreasing, this looks increasing, not like that. See theta properly. Theta is decreasing, tan theta is decreasing. Tan theta of velocity time graph will give acceleration. Acceleration is decreasing. It means, what is acceleration? Rate of change of velocity, right Indumati? So, rate of change of velocity is decreasing. It means that velocity may increase, but at a decreasing rate. Initially, it may increase very huge, then it may increase little slowly. The same thing is happening here. When he drove the car, from 0 to 130 he went in 4 seconds, but the first second he went 0 to 60, then 60 to 100, then 120, then 130. So, whether his velocity was increasing? Yes, it was increasing, but not increasing at a constant rate, not increasing at an increasing rate, increasing at a decreasing rate. Velocity is increasing, rate at which the velocity is increasing is decreasing.
So, but this case is not constant, like fixed for everything or something. The graph which is looking like this will apply this on the graph.
Obviously, no, you are thinking, or you are saying that whether it can be something else also.
Like I'm asking
It can be, why not?
Then how we can conclude that that graph is their velocity is increasing, acceleration decreasing?
I'm not concluding that. I'm trying to say that if acceleration is reducing, does not mean that velocity will definitely reduce. Velocity may reduce or may increase also. Are you getting? Because generally our mind thinks that A is decreasing, velocity will reduce. No. I am trying to make only one point here. Decreasing acceleration is different from negative acceleration. Negative acceleration means retardation, deceleration. But decreasing acceleration means rate at which the velocity is changing is reducing. Velocity may increase. But if it is retardation, velocity itself will reduce. No, you are in 11th.
Then in that case, acceleration can increase.
Can in which case? 1 second.
Retardation case.
Can?
If negative,
Retardation case, can acceleration increase?
if negative
Yeah, can be. But velocity should decrease. Possible what you are saying is. Yes, Priti, something you are saying. I said that in the case of negative acceleration, the velocity may increase or decrease. It cannot be constant. It should either increase or decrease. But the rate at which it is increasing or rate at which it is decreasing will always decrease in decreasing acceleration. But if it is negative acceleration, velocity will definitely reduce. Negative acceleration means what? Retardation. Something is stopped. So velocity will reduce. But negative acceleration means rate at which the velocity is changing is becoming less. So initially it may have more change, then less change, further less change, further less change. That's only happened. Increased at a very high rate. Then the rate at which it was reducing reduced. Kept on reducing.
Sir, is this the hardest topic in this lesson?
You are sitting with Lalit Ramna, asking questions like Lalit Ramna only. Then hardest topic, easiest topic, what is there in that, man? See, hard or easy is purely depending upon how you are studying. If it is clear to you, it is easy now.
Yes, it is.
Go and ask somebody in this class, it will become hard for them now. So it depends upon how much you are prepared. If you are knowing something, it is easy. Not knowing it is tough. So don't say me tough or easy. Everything is easy if you are good prepared for that. Yes, Mr. Lalit.
ஏதாவது ஒரு கேஸ் வெலாசிட்டி இருக்க வாய்ப்பு
நிறைய வாய்ப்பு இருக்கு. Yes, no, I told no negative velocity. Object going up, object coming down. It can be negative. Okay. Last case. I know it is torturing for the people who came for Sunday's class because same kind of topic is being repeated. Don't worry, within some time we will make it. Okay, let us see pakka or not. So, VT graph. Now, Soumya, if you are hearing me, last time also I took your name, you not replied. Soumya, you hearing me? She hears, but she is not replying itself. No need of answering anything. You are hearing, Soumya? Please, if you are hearing, unmute yourself. Alamelu ma'am was praising about you. She was saying you are a good student. Unmute yourself. Please. Sivesh, at least you unmute yourself, ma'am. Shall I ask something, Sivesh?
I'm not sure if I can answer.
Why? From last half an hour you are in your own world? If you are hearing the class, then you should answer. Graph is in front of you. Comment on the graph, Mr. Sivesh. 100 marks in math, no, in 10th standard. What, Sivesh?
It's a bit confusing.
What?
It's a bit confusing.
What confusing here? Whether theta is changing here? You are absent actually. Mentally you are absent in the class. Madhuvanti, I hope you will say the answer correctly.
Sir, can you hear me?
I can hear you very clearly. Please go ahead.
Sir, the theta is constant.
Great. Yes, you are right.
Okay. So the tan theta is also constant.
Yes, perfect.
Therefore, the acceleration is 0.
Very bad. Theta constant, tan theta constant, then acceleration also is constant, Madhuvanti. All my hard work went in water. Huh? Understood or not, Madhuvanti?
Yes, sir.
Yes. Now tell me, Madhuvanti, acceleration is constant, right? Say yes or no.
Yes, sir.
In this graph also A is constant. How are they different from each other?
Sir, it is negative acceleration.
Very good. It is negative acceleration. And why I say negative acceleration? Because theta is obtuse. Tan theta is obtuse. Are you getting my point? And I told in the previous slide itself to you that if theta is obtuse, then it will become negative. Minus, man, minus is important.
That means in that case acceleration can increase also.
Acceleration can? In constant came, then how it can increase?
Sir, that is so fast acceleration.
So you say negative acceleration means velocity will reduce.
Velocity will reduce, but at a constant rate. Pakka it became, no? So, in this case and this case, in both the case acceleration is constant. It means velocity will be changing for sure.
So this can't be called as deceleration.
Which one? Second one.
This one, sir. Yes, sir.
Obviously it is deceleration only, man. A is negative.
Sir, I'm actually confused between the retardation and deceleration.
Both are same, man.
I'm really confused.
Like Shri Krishna is same as Skyrix. Same way, Skyrix is its DP photo name is the Skyrix. So Shri Krishna and Skyrix are same way. Displacement and sorry, not displacement. Deceleration and retardation are same. Retardation is same as deceleration or negative acceleration. Okay, Mr. Shri Krishna.
Okay, sir.
Okay. Yes. Anybody has doubt? What, Mr. Lalitharam? How A negative? Something is constant, it cannot be negative. Okay, I'll repeat. I have a lot of patience. I have patience, lot of patience I have. I control myself. Okay, please, guys. I am repeating once again. I am once again explaining you the difference between the second graph and the fifth graph. Please pay attention. In the second graph and the fifth graph, in both the graphs, theta is constant, tan theta is constant. Tan theta means slope. Slope is constant. Slope of VT graph gives acceleration, so acceleration is constant. But in the second graph, theta is acute. Being acute value, tan theta will be positive. Here theta is obtuse. Having an obtuse value, tan theta will be negative. So negative acceleration means what? Retardation. Retardation means what? Velocity should reduce. So difference is, in this case, velocity is increasing. In this case, velocity is reducing. If you ask me example, for everything I have given example, for this also I will give example. Example can be Guru Sharan is driving the bike or driving helicopter. What do you want to drive? Man? What do you want to drive? So from at time is equal to 0, velocity was 0. Okay. Then in next second, since he is driving helicopter, went directly to 120 meter per second directly. Okay. And then from 120, he came down because he is driving in hills. So he came down to 80. From 80, he came down to 60. Let us stop here. So if you see in this 1 second, how much is the acceleration? 80 minus 120 by 1, minus 40. Okay. In this minus 20. So this is the wrong example I gave. Let me go like this, because constant velocity, no. So I'll write like this: 0, 120, then 100, then 80. Now you see. Now it became how much? Minus 20. How much? Again minus 20. What will happen next value? 60, 40, 20, like that. So now you see that acceleration is constant. How much? Minus 20 meter per second square. But it is negative. Where in the first case, it was constant, but what? Positive. So if you are driving a bike 0, 20, 40, 60, 80, 100, this is the graph. If you are driving from 120, 100, 80, 60, 40, 20, 0, this is the graph. Got my point?
Yes, sir.
Is all the graph clear to you? Once again, that kind of graph not possible. Same like previous thing, if you have graph like this, not possible. At same time, you cannot have two different velocities. Not possible. Are you clear in all the graphs?
Yes, sir.
Good thing is, 80 graph slope gives no information. So, we will not learn about 80 graph. At least the slope part. You can copy what you want to copy. Take 2 minutes and copy fast, fast, fast. Huh? You want to drink water?
Thanks, sir.
Come on, come.
Come just
Yes,
lift
sir.
us.
How to determine velocity you are saying?
Yes, sir.
How to determine velocity means what, man? In this VT graphs, velocity can be determined directly by seeing how the graph is changing. From VT graph, we try to determine the acceleration.
Yes, sir.
Okay, if you ask me how to determine acceleration, then I will say you that by looking at a theta, you can determine the acceleration. In the first graph, theta is 0, tan theta is 0, so A will be 0. Here theta is constant, tan theta constant, acceleration constant. Theta increasing, tan theta increasing, A will be increasing. Like that, by seeing theta, you can determine what is the acceleration in the case of VT graph. If you ask me, I want to find VT graph velocity. Very simple.
Yes, sir.
Suppose the value here, I have drawn a graph like this, and I have given value as 10, 20, 30, 40, 50 seconds, and here 0, 10, 20 meter per second. If it is 20 meter per second, and I draw a graph like this, it means that the vehicle is having constant velocity of 20 meter per second, isn't it?
Yes, sir.
But if I ask you what is acceleration, answer is 0.
Yes, yes, sir.
Are you understanding my point? So finding velocity from VT graph is simple. Directly you can see the values. But finding acceleration from VT graph is only what I have taught you now.
Yes, sir. Yeah, right.
Okay.
Yes, sir. Thanks.
Okay. Anybody else wants to ask something? Fast, fast.
Sir, then in the first case, velocity is constant, right?
Obviously constant. A is 0, no? Yes. Negative acceleration, retardation, deceleration, everything is same. Can I proceed further? Make it fast, please, if you are writing something. Hmm? Loudly. What is same? I hope it is clear to you. Something is clear to you? So you know that positive acceleration means velocity is increasing. Negative acceleration means velocity is reducing. Increasing acceleration means velocity is increasing at an increasing rate. Decreasing acceleration means velocity may increase or decrease at a decreasing rate. I will repeat once again. Listen. Once again I am saying, positive acceleration means velocity must increase. Negative acceleration means velocity must reduce. Zero acceleration means velocity will remain constant. Increasing acceleration means velocity may increase or decrease at an increasing rate. That is, if velocity is increasing, it will become 0, it will become 40, it will become 100, it will become 200. So the rate at which the velocity is increasing. Same way, if it is decreasing acceleration, velocity may increase or decrease, but at a decreasing rate. So increasing acceleration or decreasing acceleration is all about rate at which the velocity is increasing or decreasing, rate. But positive acceleration and negative acceleration is about increasing velocity or reducing velocity. Okay? And if it is zero acceleration, velocity will not change itself.
It will be constant.
Yes, it will be constant. I hope you are clear in this. It is more than enough for the graphs for school level. Then comes area under the graph. Very simple topic this is. So usually when the question comes from area under the graphs, question comes from either VT graph or AT graph. AT graph question is rare, very rare. Mostly it will come under the case of VT graph only. So there will be some graph given like this, and then they may ask you what is the distance covered or what is the displacement by the body. In this case, if a graph comes like this, and what you will do, you will find the area. Suppose I find the area, and the area is A1, and I find this area is A2. Now actually area A1 is positive, isn't it? And A2 is actually negative because it is negative side. If you add A1 plus A2, you get distance covered. And if you write A1 minus A2, you get displacement. It means if you add the areas considering the signs, you get displacement. If you add the area, just the magnitudes of it, you get distance covered. Are you getting my point? So suppose a graph is given like this, where you have graph like this. Then 1 plus 2 plus 3 plus 4 will give you distance covered. 1 minus 2 plus 3 minus 4 will give you displacement. I will repeat once again, Guru Sharan, pay attention. If you are adding all the areas without minding its direction, add everything, 1, 2, 3, 4, add, you will get distance covered. If you mind the directions, for example, here it is negative, negative, positive, positive. So you will write 1 minus 2 plus 3 minus 4. That gives you displacement. Got my point? Very simple. So if area is found under the graph, that gives you the value of distance or displacement. If you are considering the signs, displacement. If you don't consider sign, distance. Copy this fast. Copy this fast.
Can you repeat?
If
You cannot understand.
I'll repeat, man. If you have a graph given, okay, and they have asked you to find the distance from a VT graph, then what do? You add the areas. For example, I am drawing a graph for you to make you understand. Suppose this value is 1, this value is 2. Velocity in meter per second. And decide you have 1, 2, 3. Time is given in seconds. And I am drawing a graph like this. This is -1. Now, there are two areas here. This area is how much? Half into base into height, which will be half, base is 2, height is also 2. So, it will become 2. And here what is the area? Length into breadth. Length is 1, this is also 1. Actually, it is minus, so I will take it as only 1. So, basically it is 1 into -1, so I will take -1. If I do 2 plus 1, I will get distance. If I do 2 minus 1, I will get displacement. Are you getting my point? I said that if you consider the sign positive, negative, and then add the areas, you get displacement. If you just add the areas without minding about positive, negative, you get distance covered. Got it? I hope you got it.
Yes, sir.
Yeah.
Sir, how will they ask the questions regarding?
They will give some like this graph, they will give like this, and they will ask you find the distance covered or displacement covered.
Is it 2 marks, sir?
Yes, this also is possible. As you are saying, Lalit, they may give some values to you. You have to plot the graph and find the area. That also sometimes happens. They will give x, y coordinates, draw the graph, and then find the area under the graph, get the answer. That also may happen. Shall I proceed further?
Yes, sir.
Okay. Now, by knowing all the graphs and what the graph helps you in finding, let us derive the equations of motion. In the previous class, could I derive by using differentiation integration? I not did here in this class. I don't know whether I did or not. No. Okay. So, first let us derive the equations of motion with the help of graphical method. Everybody stop writing, listen for 2 minutes. I will give time for copying. Already we will have video also. Whenever you want to copy, give me 2 minutes, please. Important thing, simple thing which you have learned in your 9th standard, repetition of that. So, let me assume there is a body having velocity u. I am drawing a velocity time graph. So, I am considering a body having an initial velocity of u. Okay. From time t is equal to 0, in some time t, by accelerating, its velocity has been increased from u to v. And how much time it has taken for this increase? T. So, velocity has got increased from u to v in time t. Graph is clear to you? It is a velocity time graph. Initial velocity is u, final velocity is v. How much time it take for this velocity change? T. Okay. Just before some time I told you, slope of VT graph, what it gives you? Good. Gives acceleration. So, what is the slope we can find? Coordinates. What is the coordinate of this point? X coordinate 0, y coordinate u, x coordinate t, y coordinate v. Am I right?
Yes, sir.
I wrote xy coordinates. So, the formula is y2 minus y1 by x2 minus x1. So, what? V minus u by t minus 0, isn't it? V minus u, t minus 0. So, what will be A become? V minus u by t. So, what will be t? T will be, or I should write AT will be V minus u. So, I can write V is equal to u plus the first equation of motion, isn't it? Everybody agrees to me? Simple thing, very simple thing.
Yes, sir.
Next is the area under the graph. What does it give you? Area under VT graph. Loudly? Yes, gives displacement. Gives displacement. So now I am having two ways of finding area. First I will do addition of this rectangular area and then I will add this triangular area. So I will write area 1 plus area 2, right? What is area 1? Length into breadth. Length is how much? T. And what will be this? U. So I can write UT plus this triangle, half into base into height. So half into base. Base is how much? T. And what is the height? This height is how much? How V are? V is total height. This is V, this is U. V minus U. What is V minus U? AT. Let this be equation number 1. So S will become equal to UT plus half into T into AT. How AT came? From equation 1. I hope you agree. So S will become equal to UT plus half AT square. What is that? Second equation of motion. Simple. Third, I am finding the displacement only, but now I am taking area as area of trapezium. I hope you know what is the area of trapezium. Half into sum of the parallel sides times height between them. If you forgot this from a small class, if you have a trapezium, this is A1, this is A2 and height is h, then the area is half into A1 plus A2 times h. This is the formula for area of trapezium. By that formula, half into, what is this A1 plus A2? This is U, this is V. Am I right totally? So I will write U plus V or V plus U into height is how much? Time T. Then S will become equal to. So from this equation, I can write what is T. T is equal to V minus U by A. Let this be equation number 2. Since it is equation number 2, I can write 1 by 2 into V plus U, and instead of T I can write V minus U by A. How it came? From equation 2. Now what is V plus U into V minus U? V square minus U square. So S will become equal to V square minus U square by 2A. So from here you get V square is equal to U square plus 2AS. This is the third equation of motion. Just
Explain again the third equation.
third equation, what I did here, Kanishka, I have found the area of this whole trapezium. Okay, area of trapezium gives you half into sum of the parallel sides into height. So here one side is U, one side is V and the height is T. So I wrote half into V plus U into T. Are you clear in this, Kanishka? Then I have got the equation AT is equal to V minus U. If I rearrange the terms, I will get T is equal to V minus U by A. Right? So that value of T I am putting here. Instead of T I am writing V minus U by A. So V plus U into V minus U gives you V square minus U square. So S is equal to V square minus U square by 2A. So you will get V square is equal to U square plus 2AS. Simple derivation, very simple derivation. Just by knowing the graph, you can derive all the three equations of motion. If you have understood this, take 2 minutes and copy it fast.
From AP, how do you come as 80 square?
T into 80 square. How 80 came here? V minus U is 80 from here. Then T into 80. T is there, it's not plus here, T.
That's plus.
Plus is here, yeah.
I wonder how the plus came with the T.
This is plus. Okay. I'll write once again if you want. My handwriting is that bad. UT plus half into T into AT. Looks better? Yeah. So as you complete, you can start moving. Those who are in online can stop dropping one by one after copying. And those who are, yeah, take care, good night, bye-bye. Yeah, tell me, Sarvanaram.
Thank you, sir.
Sir, can I leave?
Yes, you can leave, man. Swati? Take care. Bye bye. Yes, today your mom came. I have added you.
Okay, sir. Thank you, sir.
Yeah. Drop, man.
Thank you.
Bye bye.
Sir, I have a doubt, sir.
Please ask me, Kishore.
Class, there is any special class for attending?
Special?
Because I did not attend the unit and measurement class.
Units and measurement class video I will send to you, man. You go through it, you take the notes from there, and you tell me which topics you have doubt. I'll keep a separate class for you. I may even come to SSM Nagar and teach you.
Yes, sir.
Okay? But before I come to teach you, you should take the notes from the video and come with doubts to me. Okay?
Okay, sir.
Okay.
Yeah. Okay.
Yes. Okay, man.
Thank you, sir.
Take care.
Okay, yes.